Hello and welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civy and today's topic is what is comfort? If you ask a room full of people, what is a comfortable room? You'll probably get a bunch of different answers. So what does it mean to be comfortable? Basically, you're comfortable when your heat generation equals your heat dissipation. Okay, let's scoot this out of the way. Okay, let's look at this. In the first podcast, I said that people are equivalent to a 100-watt light bulb, but not everyone's exactly 100 watts. Some people are 80 watts, some people are 120-watt light bulbs. Your heat generation is a function of your volume, which is a function of your radius cubed. I know we're not spheres, but this kind of makes it easy. Your heat dissipation is through your skin, which is a function of your surface area or your radius squared. So the relationship between heat generation and heat dissipation varies with your radius. Or the larger a person is, the more heat they can generate, and therefore they're typically warmer. Also, the more active a person is, the higher their heat generation. ASHRAE calls how much energy you generate a MET. I won't go into the details of the MET here, but you can read about it in ASHRAE Standard 55, Thermal Conditions for Human Occupancy. For reference, a person walking around an office may have a MET of 1.7, while someone sitting at a desk might have a MET of around 1.0. Differences in clothing can also affect if a person is comfortable. The ASHRAE unit for clothing insulation is called a CLO. Clothing differences aren't as pronounced anymore in offices because a lot of offices are business casual. But think back to the last wedding you went to. The men were wearing suits. Let's draw this guy in his little suit. And the women were wearing dresses. Let's draw his wife in a dress. Put some nice shoes on her. Okay, what usually happens at the wedding is the men are hot in their suits and their shirts and their ties, and the women are cold because they're wearing dresses. At the wedding, the men are probably a 1.0 CLO, and the women are a 0.5 CLO. Again, you can read all about CLO in ASHRAE 55. With so much variation, how can an engineer design for comfort? Luckily, ASHRAE has defined parameters that have been shown to maintain comfort. There are several variables that affect comfort. First, there's the MET and the CLO, then the air temperature, the radiant temperature, the airspeed, and the humidity. We really can't do anything about the MET and the CLO. We have no control over that, but the other ones we do, the temperature, the airspeed, and the humidity. ASHRAE 55 says that a comfort range can be defined in terms of a combination of air temperature and mean radiant temperature, and goes on to describe the graphic method for determining the comfort zone that is acceptable for use for many typical applications, and the predicted mean vote, the PMV, model that uses heat balance principles to relate the 6 key factors to thermal comfort. While these are all very important parts of ASHRAE 55, this goes way into more detail that I want to discuss in this comfort podcast. So we'll save ASHRAE 55 for a future podcast. So we're going to make it a little simpler. A previous version of ASHRAE Standard 55 said that comfort was maintained at temperatures between 73 and 79 degrees in the summer and 68 to 74 degrees in the winter, both at a dew point of 36 degrees. The dew point is the temperature at which air can no longer hold all the water vapor that's in it, and some of the water vapor will condense into liquid. Unlike relative humidity, which is a relative measure of how humid the air is, the dew point temperature is an absolute measure of how much water vapor is in the air, and therefore it's usually a better measure of how humid it is. So ASHRAE 55 also states a maximum dew point of 62.2 degrees. Let's make a little room on the page here. Standard 55 says that the maximum airspeed is 40 feet per minute. in the occupied space, assuming you're within normal temperatures. You can have higher airspeeds if you have higher temperatures. As a good rule of thumb, for each degree of temperature rise, you can have an increase of about 15 feet per minute and still feel acceptable to most people. There are a couple other requirements for comfort in ASHRAE 55. It says that the difference in temperature from the ankles to the neck for a person who's seated should be no more than 3.6 degrees, and for a person who's standing be no more than 5.4 degrees. It also states that the floor temperature should be between 66.2 and 84.2 degrees. So as a rule of thumb, in a typical office environment, a temperature between 73 and 79 degrees in the summer, a maximum dew point of 66.2 degrees, a maximum airspeed of 40 feet per minute, a differential of 3.6 degrees if they're seated or 5.4 degrees for someone standing, and the floor being between 66 and 84 degrees will help you maintain comfort in a space. So that covers the basics of comfort. Thanks for taking the time out with us.